Okay, hi everyone. We're trying this new method today because last time we couldn't have as many people on our Google Hangout calls as we wanted. There's a maximum of 10. So I'm trying this Google Hangouts on air, which means that this video will be broadcasted live on YouTube. And so anyone who can't get into the Google Hangout call can go to YouTube and just click the link that I sent, and that should go directly to the page for this video. So I also sent out the Google Hangout invite, so potentially I'll be having some people join us on this call if they get that Hangout invite. I know that sometimes doesn't, sometimes those don't get to you guys for some reason, but those are the options. And I was also hoping that in future sessions, when I have students live in class, which I don't right now, I was hoping that when I do have students live in class that I can have someone kind of field questions that come in from online, especially from YouTube viewers who can't really communicate with me as easily as they might like to. So I was thinking about having someone manage that in class in the future. So maybe if someone shows up today, we'll be able to have that as an option. You can either text or email your questions to that person, and then they can make sure that you ask me if you need any clarification questions, like while I'm working on things. Earlier this week, I sent out a Google form survey and invited you all to respond and let me know what questions you wanted to work on first, so that I didn't have to pick and choose what questions to go over during the phone call, or during the, not phone call, hangout call. From that, I didn't get a ton of responses. I think only like 10 or 12 responded. And that's okay, but if you do have questions that you want to go over specifically, just make sure you do respond, and I'll just go over whatever is the most requested. So today, what was most requested are problem sets 4 and 5. Pretty much all of problem set 4 is requested, and then a few questions on problem set 5. Let me go to my little survey response and see. So we'll probably also go over all of problem set 4. We probably skipped the review since we did that in the last session. Even though there was one request for some review questions. And then if we have time, we can go back. And then we also got problem set 5 requests for problems 2, 3, and 7. So if those are problems that you want help on, then this will be a hopefully productive hour and a half or 2 hours for you. And then the last thing I wanted to say just before I start with the actual econ is that I'm really excited about this method because there have been people that have asked if there's any way that they can get the Google Hangout recorded. And this is a way for you guys to all be able to look over this video later, and or if you can't make it to this office hour, you know, at 8 in the morning on Saturday or 8 p.m. on Tuesday, you can go and watch it anytime that you're available. And so that's good. I think that that'll be a good thing for all of you guys who can't make it. Okay, so I don't have anyone in the call yet, but looks like I have some viewers online, 4 of you. So yay, people are figuring it out. Yeah, I guess I will get started on problem number 4. Or not problem number 4, problem set number 4, number 1. So this is the, I'm actually going to mark the board where you guys can see so I don't have to keep wondering. So I'm going to go problem set 4, number 1. This is the question about co-op gardens, and includes average and marginal cost curves and average total cost curves. So the question says that you run a social venture that helps communities to plant cooperative gardens. The co-ops donate most of the gardening inputs, but you have to employ social workers to help the co-op garden organize itself. Each employee costs $40,000 a year, and you pay $60,000 for office space. So part A says fill in the columns for fixed costs, variable costs, and total cost. I'm going to go ahead and make the remake the chart that is in the problem. Let's see here. Okay. So our first column is going to be our variable input, which are employees. Those are the things that we can vary to increase or decrease the number of gardens and also the number of variable costs that we incur for this project. So let me see how many more I'm gonna need to do. Maybe if later on I need to go back and add more, but that's all I got room for. So, so we can have varying numbers of employees, which will lead to varying numbers of output. So the next column is the product. These are the number of gardens that we have. Okay, so when we have 0 employees, we have 0 gardens. When we have, and these numbers are all given to you, so I'm just recreating what Mr. Curley has. With 1 employee, it's the same that they'll have 50 gardens or output. With 2 employees, output is by 100. So it goes to 150, and then 350, 70, 320, 360, 395, and 420. Okay. Next column, fixed cost. So the fixed costs represent the sunk costs, so the costs that you have to spend no matter how many you are. Hold on one second, I have someone else. Okay, we got someone in the class now. Okay, so fixed costs represent those costs that you can't avoid in the short run. You can only change them in the long run, and so no matter how many employees you're employing, you still have to pay for the building. So office space. And that was, I think it's 60,000 a year. Yeah, so it's just going to be 60,000 a year no matter what. Until you get to the long run, you can't avoid this. Jim, I'm broadcasting this live on YouTube. I don't know if you got a chance to see the email, probably not, but we have a lot of viewers online, but not very many, or none right now on the call. since people are watching on YouTube, they can't ask me live like questions if they need help with like any clarification items or anything. So, what would you think about or okay? And what was your last name? Do they all have your email address? Okay. Okay, guys, sorry about that. We have a student in the class now. Jim Woodard is here, and so I put his email address up on the board. If you do have any questions as I'm going over this and you can't call in or anything, then the best thing would probably be to email him, and he'll try and field those questions and ask them for me, ask them for you guys to me, so that you can get the questions answered. Okay, so the next column we're going to go over is the variable cost. And this represents the cost of the employees that we've already put over here. So each employee costs $40,000. So you just multiply whatever numbers over here times 40,000. So 40,000 for one employee, 80,000 for two, 120 for three, 164, 200 for 5, 40, and 280. Okay. Okay, and the next one we're going to go over is we're just going to make a total cost column and list the total costs of running the co-op at each of, depending on the number of employees and the number of outfits we have. So here we're just going to want to add up the fixed cost that we determined, which is $60,000 no matter what you do, and then the number of employees times $40,000. So we can just add up the columns to get this next column. You get 100,000, 140, 180, 220, 260, 300, and 240. Okay, so this is the total cost of running the co-op. Okay, now we're going to get into the average costs. So next column is our average. The average variable, yeah. So the average variable cost column represents the amount that you spend on salaries per garden. Okay, so this is the additional amount that you spend on each additional, an average amount that you basically spend on each additional garden. Okay, so to get this, let's see here, the average amount that you spend per garden, your variable costs to be your variable cost, oh no, yeah, it's going to be your variable cost divided by the number of gardens, okay? So here we don't have any variable costs, so, and we also don't have any gardens, so that's actually 0 divided by 0. Here it's going to be 40,000 divided by 50. Let me get my calculator out. So $40,000, so one employee divided by the number of gardens that that employee can produce, which is 50 gardens, means that you are spending $800 per additional garden. Okay. Here we have 2 employees, so it's $80,000, and those 2 employees together can produce 150 gardens. And so how much are you spending per garden? It's going to be 80,000 divided by 150. So 533. Here it's going to be 120 divided by 270. Which is 444. Here it's going to be 160 divided by 320. So it's going to be 500. Here it's going to be 200 divided by 60, which is 556. And then it's going to be 608 and 667. Just doing that the same way, taking our variable cost divided by the number of gardens that we're producing. Okay. Next, we're going to do our average total cost. So here we're just going to take our total cost divided by the number of products that we're producing, so our garden, we're going to get our average total cost that way. I'm just going to take the numbers from the PowerPoint, so let's see here. So we're going to take our total cost divided by the number of gardens. So here, can't divide by 0. Here it's going to be 2,000, it's $100,000 for a total cost divided by 50 gardens. So each garden on average is costing us $1,000 at this point. Okay. For this point, we have 2 employees. We're spending a total cost of $140,000, and we are getting 150 gardens out of it. And so our total cost per garden is it's going to be 140 divided by 140,000 divided by 150, which equals 933. So that's the total amount on average that we're spending per garden. And I think that the prompt said we're selling them for $1,000. So this is the point at which you begin making money, is if you have 2 employees and you're producing that much, 150 gardens. Okay, when we have 3 employees, the total costs are going to be 180. We're going to come up with 270 gardens, and the average total cost then is going to be 180 divided by 270, 180,000 divided by 270, and the average total cost is going to be 667. Same thing with the following ones. We're just going to divide our total cost divided by the number of outputs we have. So I'm just going to fill the rest of these in now. 722, 759, and 810. Okay. And now we're going to get to our marginal costs. Okay, so this is the amount that we have to spend for each additional garden that we produce. So that means that we are looking at let's see here. Hold on one sec. So we're going to look at the number of gardens that changes from one employee level to a new employee level. So from here, we'd be looking at the number of 50 to 150. We're looking at the number 100, the difference between them. And if we want to know how much each of those additional gardens costs us, we are going to we're also going to look at the change in the variable costs, which is going to be the difference between one employee level's variable costs and one employee level's, and the next employee level's variable costs. So we're going to look at the change from 40,000 to 80,000, because these are the things that are varying. We want to know how much our prices are going to vary per garden. And so the difference here is going to be 40,000. You can fill these in if it helps you. You don't have to. I think it would help me. So from each of these, in each of these areas, it's going to be 40,000, right? It's only going to go up 40,000 in each of these. And over here, the number is varied, which is why we're going to get different marginal costs at each of these employee numbers. We're going to have, let's see here. Yeah, so we're going to have our cost divided by the number of gardens to find out what what the average price of each additional garden is costing you. So you're not counting your fixed costs. And so it's going to be 40,000 divided by 100. And here it would be, let's see, this is a difference of 80. 150 to 270 is a difference of 80. So here it would be 40,000 divided by 80, and so forth. So you could do this one. And here it would be 50. Here it would be 40. Here it would be 35. Here it would be 25. You can fill those in if you'd like. So I'm going to fill those in just by doing the division of 40,000 divided by the numbers that I've just put in here. Okay. So our marginal cost. Let's see, we can do it here as well. And our marginal cost here is also 40,000. Our variable cost there is also going to be 40,000. We're going from 0 employees to 1 employee. Okay, so it's going to be 40,000 divided by 50. So our marginal cost there is $800 per garden. Here it's going to be, right here on this line, it's going to be 40,000 divided by 100. So it's going to be 400. So the cost of adding each additional garden is going to be going down for a while because we're getting more efficient as we add more employees. Eventually, it might be the case, well, it will be the case, that when we add one additional employee, we're not actually making, making any money, because eventually at one point when we add a certain number of employees, output won't increase enough, but won't increase by enough that we can have a marginal cost below $1,000, and that's the point at which it's not profitable to keep scaling your business. So let's see here. So it's going to be, here it's going to be 48,000 divided by 80. So it's going to be 333. Here it's going to be, this would be 40,000 right here, just like it is everywhere else in between. So it'd be 40,000 divided by 50. So we go back up to 800. Yeah, 800. So here we're starting to see those costs are going way up because we are starting to see, I mean, here we had an additional 80 gardens for an employee. Here we only had an additional 50 gardens for an employee. Here we're only going to have an additional 40 gardens per employee. And it's just going to keep going down because maybe your office is getting too cramped. Maybe your employees are getting distracted because there are too many people in the office and they're having too much fun. For whatever reason, a number of gardens that we have, maybe it's just the case that there are only so many people in the community that want gardens. And so even if you add 50 employees, maybe it's the case that you're never going to have more than 500 gardens. So that could be why our marginal cost is going down. Eventually, it's just going to cost too much to find that last person who wants a garden and advertise to them or reach out to them or find them or whatever it is. Okay. So here it's going to be, so we already did the $800 one. So here it's going to be $40,000, the difference between these two, between this and this. Cost of adding one additional employee divided by the number of gardens that that employee can get, which is 40. So it's going to be $1,000. So this is an important point, right? This is the point at which it is not going to be profitable anymore after this, probably, to increase the number of employees, because then your marginal costs are going to be greater than your, in the short run, you don't want to add any more employees. In the long run, you also wouldn't, so you wouldn't do anything in the long run at $1,000 for marginal cost. But that's the point at which, at the short run, you also drop out of the market and you say, whoa, even my variable costs are exceeding what the revenue that I'm receiving, and so it's just not worth it anymore. I can't even make back any of my my long-term costs at this price because I'm not making any money and any additional money for additional gardens at that point. Okay. So then after that, it'll be $1,143 for your marginal cost. That's going to be the 40,000 here divided by 35. Here it's going to be 40,000 divided by 25, which is going to be 1,600. So yeah, we're seeing those costs just go up a lot after that because of that decreased output for an employee. So now you had a few more rows than I did. I just couldn't fit them all on the board. All the numbers are in the PowerPoints though, so you just calculate them, just continuing the way that I showed you. So let me look at the next portion of that problem. Okay, so we've just done A, part A. Oh, and we've done part B as well. Part C says that there is a going rate for community gardens that several foundations are willing to pay. Right now, the rate is $1,000 per garden. So using the information in the table, how many employees will you hire? Okay, so this is kind of just what we just went over. In the long run, if you have several years that you're looking at and you can actually get out of the your fixed costs, you can get rid of the building and everything like that, you're going to have a different answer for this question than if you're just looking at the short run. Since we're going to assume that we already have the building with us, we already have rented it or entered into a contract, we're just going to assume that we're stuck with these costs. It doesn't matter if you sell 0 gardens, you're stuck with these costs. So now what we're interested in is going to be let's see here. Okay, so now we're going to be interested in is only the marginal cost per garden. Okay, so if it's $1,000 in revenue per garden that was available to us, then we want to know at what point are we not going to make any more money by producing additional gardens, and that's how many employees we want to hire. So over here we see that we put making any short-term profit at the point $1,000, right? This is our marginal cost. So this is the point at which you probably stop hiring employees. Okay. So how many employees in gardens does that correspond to? Let's see here. It's going to be 5 employees and 360 gardens. So we found the marginal cost by looking at the difference between this 160,000 and this 200,000. So you go at $40,000 there. So the marginal cost there is the variable cost there is $40,000. You get 40 additional gardens out of this jump, and so you want to stop there. So you would then hire here. So you hire 5 employees. Okay, I'm going to turn off this something really quick. I'm going to move this over a little bit so that you guys can see the graph, and maybe I can angle this somehow. Sure, yeah, we have a question in the class. The total cost? Yeah. Okay, that's what you would do in the long. Okay, so Jim just asked me, he said that you tried to find the number of employees you'd hire by looking at your total revenue. Wait, you said it, say it again.
Well, so I took the number of gardens produced, but I multiplied that by the $1,000 to get the total income that I would have received.
Yeah.
And then I didn't know if I was looking at marginal cost, so I started at 5, and that was the right place. Maybe I could give it. But so I got that cost, and then I subtracted out what my total average cost was.
Okay. So you wouldn't necessarily, I'm not sure how you calculated it, but you wouldn't want to multiply your average total cost. Yeah. You wouldn't want to use, Jim has asked, he tried to calculate the number of gardens or the number of employees he would hire in a different way, and he used, I can't remember exactly how he did it, but he thinks he used average total cost times the number of.
Find out what my
Okay. Right. So that was so. First.
Then I subtracted the 2
calculated his revenue, and then he calculated his cost, and he just subtracted revenue minus cost to find out which of these points he broke even. So he used the number of gardens times the charge per garden, which is $1,000, which would have given him his revenue. And then he multiplied his average total cost, which is this column. So he probably tried multiplying each of these numbers times, and he just did it systematically like that. Oh, sorry, this isn't average. So he probably multiplied $2,000 times the number of gardens, which was 50 in that case, and 933 times 150 and so forth, until he found out where his cost exceeded his revenue. That would be a great way to determine in the long run if you want to keep producing. Okay, because your average total cost takes into account your fixed cost. So you're looking at this column divided by, your total cost column divided by the number of gardens to get your this average total cost column. Which actually I'm going to start doing the next part of the problem because I think that it can answer it. Once we graph it, I can show you how the difference between the two and how your fixed costs play into it.
Probably
yeah. Right. Yeah. Yeah. And so Jim just said he had a great point. He said that it's the case sometimes that you aren't covering all of your costs in the short run, but you don't shut down. But in the long run, you would shut down. And that might be because you're recovering some of your costs for each additional sale. That's kind of what the marginal cost tells us. So if you're charging $1,000 per garden and your costs are only $800 per garden, marginal cost is only $800. And this is, so marginal cost is taking into account our average variable cost divided by the number of gardens, right? Or change in the number of gardens. Okay. So if we're selling our gardens for $1,000 each, and our cost for each additional garden is only $800, then we ought to keep selling those garden plots, right? We ought to hire a couple more employees and do that, because that means that for every additional garden we sell, you're making $200. And so even if it's the case that we're losing money once you take into account the room rental or whatever office space you need or whatever fixed costs you have, say it's the case that I'm spending $1,200 on average per garden, then by increasing the number of gardens and by getting the extra $200 per garden, difference between $1,000 and $800, or the difference between what you're charging and your actual cost, I would be decreasing the amount that I'm losing, right? Because I'd be losing money in the long run, which maybe that doesn't, I can show you in a graph too. Help it make more sense. Okay. Yeah, I'm going to graph it. I'm just going to see how exactly the question says to graph it, if there are any specific. So today, what I did was I am doing a live YouTube session. So I think that there are 7 people watching it on YouTube right now, and I asked them to email Jim if they have any questions, like need any clarification questions, and then I'll go over them now.
He says, I got it.
Okay. Yeah, that's why I was trying to repeat what you were saying. Okay, so I'll try and do a really good job of repeating the questions that I hear in the class. Some of them are just comments, but if there's a question that I'm going to go over, I'll be sure and answer. I'll try and remember to restate it. Mm-hmm. Yeah. Okay. So yeah, we got Marilee's email about asking me to make sure I repeat the question that we have in the live class, and I will be sure and try and do that. Okay, so the next part of the question says to graph the average total cost, average marginal cost, or sorry, average variable cost and the marginal cost curves. So I'm going to start with our average total cost curve. And I'm just going to draw it over here to make sure that my board is still lined up with the okay. Sorry, everybody. Just want to make it so you can see everything you need. So we have our quantity down here, the price over here. And we're going to graph our average total cost. So we're just going to look at, let's see here. So we're going to look at the, we're going to plot this along the y-axis where we have our price. These are all our average total costs. So this will correspond with our price axis. And then on the x-axis, we're just going to plot the number of our gardens. Okay. So let's see here. I'm just going to want to go up to 2,000 because that's the highest number over here that we have. Just make sure I go up that far. And 1,000. Okay. And our quantities along the bottom are going to range from 0 to about 500. So I'm going to label this down here accordingly. This is okay. There's also a little point right here, but I'm not able to draw on that. Okay, so we have at the price point $2,000, we have 50 gardens. So I'm going to mark that over here. 50 is about right here. 2,000 is right here. We're also going to have a point at 150 and 933. So I'm just going to keep going down and plotting this curve and this curve right now. Or these points together. Okay, so 150 and 933. So at about 150 we have three about we have 270 and 667. So this would go at about 270 would be like right here, and 667 would be about right here. 320, 668. I probably can't plot that one because of this bar right here. But 360 and 722, we'll plot that one. So about 360 is right here, And 722 is going to be about right here. 395 and 759. So 395 is going to be right here, and 759 is going to be about there. Then 420 and 810. So 420 and okay, so this is our average total cost curve. Probably looks something like that. Okay, so the next one we're going to try and plot is going to be the average variable cost curve. Okay, our average variable cost is going to be the same quantity column, but a new price column. So these are all the costs are all dollars. So it's going to be 50 along the x-axis and 800 along the y. So it's going to be about right here and here. So our variable costs at this point are going to be $800 per garden. 150 and 533. We'll put that right here. 270 and 444 over here. 270 and about 444. 320 and 500. I probably can't plot that on here. 360 and 566 or 556. I mean, so it's 360 and 566. 395 and 608. Probably somewhere right there. And then 420 and 667. So here is our average variable cost curve, something like that. Pressure's on. Dr. Turley just showed up. Okay, so this is our average variable cost curve. And then now we're going to do the marginal cost curve as well. I don't know. Okay, so now we're just going to look at this column and our quantity together. I will plot this in blue. Okay, so we have 50 gardens and woods. Yeah, so we have 50 gardens. Our marginal cost is going to be, actually, Dr. Turner, I have a question for you. This is one thing. So when I'm looking at marginal cost, is this a marginal cost at which of these points? Which of these points? After? At 50. Okay. Okay. So here we're going to look at the marginal cost at this point. Okay. Yeah. So here we have our point 50 along the x-axis, and 800 is going to be along the y-axis. So here's about 50 and Then we have 150 and 400. So at this point, it's going to be somewhere down here around 400. At 270, it's going to be at 333. So at about this point, it's going to be somewhere down there. And then at 320, it's going to be at 800. Plot that on the bar. And at 360, it's going to be 1,000. So about 360. It's a really unfortunate thing so far. So that's and then at 395, oh wait, that's one just did. Did I miss 360? Oh, 360 is 1,000. Okay. And then 395 is 1,143. And then it goes up to 1,600 at this point. So okay, this is our marginal cost. Okay, so now I'm going to go back to Jim's question. We talked about the difference between using the average total cost and the average variable cost when you're calculating your whether or not you should be producing. So in the long run, you're going to want to use your average total cost. Okay, that's this curve right here. So this is saying that this is the actual cost of your incurring, right? This includes the number of employees, but it also includes the initial $60,000 that you have to spend on a building. Okay, so yeah, average total cost. So if you have the long run, if you can use this curve, if you're looking beyond the point at which whatever rental agreement you have with this office building goes on, then you're going to look at this curve. You're going to decide if you want to produce and it's going to be based on whether or not you are producing somewhere where your marginal cost is above your average. No, sorry, not your marginal cost. Where it's somewhere below your average total cost. And or your average, yeah, you're going to want to produce somewhere below your average total cost. But if it's the case that you're looking in the short run, you can't. There's nothing you can do about that rental space. Then by looking at your average variable cost, which is this curve, you're going to be earning some of, like, you're still producing below average margin. So I'm looking at average margin. So it's going to be the case that you're still, up until you get to this point where you are going below your average total cost curve. These are points up here where your marginal cost exceeds your average total cost. But anything below there is where each additional item you're producing is bringing your average total cost down. So, so if you're looking at, say, this point right here, that is going to be the point 150 and 400. Then the marginal cost of producing an additional garden there is $400. But you're charging $1,000. So you're making $600 on that on each additional garden at that point, even though it's the case that you are producing below uh, your average total, even though it's the case that you're producing.
So I wouldn't want to produce with that. But not even very.
Yeah, that's the case at this point. So you're, wait a second. So here our average cost is 400. No, our marginal cost is 400 per garden, and we're making $1,000 per garden. So, I mean, if you just think about that, right? Like, you know that if you are hiring additional people at this point, then your marginal cost is going to be $600 less in revenue, right? I'm making $1,000 here, but I'm only spending 400. What? Just thinking about that, what are you going to do?
Well, I mean,
If you're, if you know that the next garden that comes is going to be worth $1,000 to you, and you also know that it's going to cost $400 to you, are you going to produce that? What's that? It's a good decision in the short run, right? You're thinking, well, I've already paid for this building, and at this point, it's only going to cost me $400 extra to keep this garden, but I'm going to get $1,000 out of it, and I probably want to do it. Our average variable cost here is, let's see, $800.
really hard to do.
Oh, it is. Okay. Sorry, I just got feedback that it's hard to hear me right now, so I'm sorry about that. I'll talk louder. So what I just said that if someone comes into you at this point, your marginal cost of producing one additional garden is $400, and the person offers you $1,000, which is the going price for a garden. What are you going to do? You know that it's only going to cost you $400 to produce that garden, and you're going to get $1,000 out of it. That sounds like $600 of a benefit for me in the short run. If we're looking at our average variable cost and average total cost curve, those can help us understand what is this, 150, 953. So this is the point where we'd be producing in the short run or the long run. Our marginal cost is less than $1,000, less than the cost of producing. Sorry, not less than the cost of producing. Our marginal cost is $400, which is the cost of producing one additional garden at that point. We're getting $1,000, so there's a good decision in the short run. In the long run, when we're looking at all of our costs together, this black line is taking into account even our fixed costs, which we could get out of in the long run if we want to. Our total cost is going to be $933, which is still below $1,000, so it's still the case that you're producing. Yeah, clearly. Yeah.
Sorry.
Okay, Dr. Turley is going to intervene real quick.
It doesn't, I mean, everything you said was correct.
I don't know if they can see me.
I want them to see me. Everything you said, but we don't, it's sort of not worth analyzing this point, this quantity very much, because we know that the only quantity we ever want to produce is where revenue equals marginal cost. So if you're talking about if the revenue is 1,000 per garden, this point doesn't matter at all. Mm-hmm. There's no way it's optimal. The only possible optimal point is 1,000 goes over to the marginal cost curve on its way up. Mm-hmm. If price is 1,000, That's the only quantity worth even thinking about. And specifically, it's where the revenue or the price hits the marginal cost curve on its way up. Because where revenue hits the marginal cost curve on its way down, that's never going to be awesome. Because your marginal cost is decreasing. The optimal rule that we learned in the lecture is produce where price is marginal cost, right? The reason that's optimal is because marginal cost is increasing there. And if you produce slightly more, the last one's costing you more than you're getting in revenue, so that's not optimal. And the one previous to the last one cost you less than the revenue. So you want to produce it. That's why that's an optimization point, the point that maximizes your possible revenue. So the order that I want us to go through is first we follow that rule. Price equals marginal cost on the upward sloping part of the marginal cost. Once you get that, that tells you what quantity you could possibly produce. And then you analyze that quantity, see if it makes sense in the short and long run, based on your average total cost and your average variable cost.
So that's the point at which you make your law.
All that kind of logic that you're doing, that's correct, but we know this point is never going to be our production point. It doesn't follow the optimal production rule.
Yeah. I just picked a random one, but should have picked not random one. Okay.
There's one that we love a lot. The price of the marginal cost.
Yeah. Okay. How do you feel about that, Jim?
Profit on the left side.
Yeah.
Well, that's what's not working. I don't see.
Because you're looking at the average total cost, or?
Well, I'm looking at marginal cost, average variable cost. I know that once I cross over, then now once I've crossed over the average variable cost, I'm at least making up my average variable cost. And I know that in the long run, I want to be above the average total cost.
Mm-hmm.
But the decision point where the graph is between the average total cost and the average variable cost. So once I get below the average variable cost, I don't want that. Am I remembering? So I guess I kind of think that it's working backwards. Once I cross over,
So is it the case
and
at
I
this
want to
point?
find
What
the
is it?
sweet spot, at what point do I want my marginal cost ever drop below my average variable cost? At that point, what's not clicking for me is, I know that in the short run I'm going to lose. And until I start bringing in enough business, I'm taking a risk that I am going to make that business as keep running. And then I start to make up at least my average variable cost at some point. About that. Not in the long run.
I would encourage you to not think about it. Don't think about it like I'm running a loss right now, and later on make it up. You're abstracting away. This thing is the optimal. The short run, long run, is defined by the length of the fixed cost, not defined by the start.
It's not defined by the point. I have to look at the year, which I define, in this case, I define my short run as that look at all. Phase in most cases, in all cases, according to well, it depends on at what point you have an opportunity to change your total cost, right? Fixed cost.
At the point at which your fixed cost could be changed and no longer fixed, however long that takes, it will not be fixed. That's the difference.
And so in this case, if we renegotiate our contract for a building price every year, our
Mhm.
Locking for 3 years, so that's. Is that sort of usually years? Well, it depends on, it depends on when you can negotiate your cost. In this case, we only got one fixed cost.
Yeah.
At that point, the only thing that makes it is tell me the price. Tell me the price. Although the upward sloping part of the marginal cost curve,
Mhm.
and I'll tell you the quantity that could be out.
Okay.
Then whether or not it is.
So it's $400. So that would be, but that would be revenue, right? So then,
You wouldn't stop on the end.
You wouldn't stop there because.
because for every additional item that you produce, you see that sloping downward. So it's going to be pulling those averages down for your cost. So you don't want to stop until it's the case that every additional item you're producing is going to be costing you more.
Well, just think. Let's say the price is $400. Right here, your marginal cost is $400. What if you decided to do one more garden? How much revenue would you get for one more garden? For another $400, because that's the price. And how much would it cost? Less than $400. The marginal cost is going down. So you wouldn't stop there. You keep making it. Because as you move to the right in quantity, increase quantity, your profit is going up for sure. So the only point you care about is when price hits marginal cost. Yep. Then you check that quantity and see if you're covering your full cost. Stay in business or not. Maybe I didn't stress this in class enough, but that's the most important thing is know you're not doing optimal behavior if price doesn't hit marginal cost. That's the first thing.
By the way, usually
This is well, this sort of gets back to your comment about.
So can you repeat the questions? Or I can just go to them afterwards.
No, I don't mind repeating. He said this is sort of true when your business is starting out.
That's basically.
Yeah, it doesn't. This is true regardless of what if the business just started or is at the end. And we're not taking into account here that someone might be willing to have losses for a while before they.
Okay, so anything could happen, recession or something else could happen.
Exactly. We did an example in class of something that would cause this to be an issue, which is an example where if demand, well, if a lot of two things happen. If a lot of corn farmers enter the market, the price goes down, which means you have to recalibrate your optimal quantity, and then you also have to decide if you should even be producing at all. Or supply or demand can go down.
Timelines.
Yeah, it's not temporal.
I don't want
No time. No. Yeah, don't think about time.
So in a question on the test, would you?
Good idea. Give me a good test.
Don't do it.
Don't do it.
Like you gave, what would cause this to happen or something? What would be the question that would be what would cause this effect? So some might think timeline. They can
Well,
stay down for long. Yeah,
It's, it's not, it wouldn't be the case that this is only like this, the graph is only shaped like this during our session. It's going to be shaped like this, no matter
Yeah,
what
you're
your
right,
product
because
is.
it's product based.
Yeah.
The base cost of input,
Yeah.
which we just demonstrated.
Yeah, whichever is the case, depending on the
Right. That, yeah, there could be, so, I mean, we just got a question in class that was, is this the case because, would there ever be a test question that said, why is the graph shaped like this? Why are the different curves shaped like this? Why is the marginal cost switching below and then coming above? Would we say it's because of the time that they're in their business, or would it be because of the economic conditions? Neither of those would be the case. It wouldn't be the case that this graph is not just shaped like this for this one problem. Marginal cost curve and average variable cost curve and average total cost curve. This is like an approximation of what this graph will look like each time. It's always going to be the case that at some input point, you add one additional tractor in farming or something, and you yield so many more potatoes. Right, and it's going to be the case that eventually, no matter how many tractors you have, there's just no more potatoes to get, And so that's just how inputs tend to work, and inputs and outputs. So it's going to be the case that maybe the first few tractors you buy, it's going to increase your potato harvest, and so your average cost or your marginal cost is going to be getting better for a while. But then it's going to be the case that for each additional input you purchase, your costs are going to skyrocket. Is it worth another tractor to find that last potato? Probably not. Definitely not. Yeah. Yeah.
Doing great.
Thanks. Thanks for coming. You can find us on YouTube.
Fine.
Oh, you are? Okay. Okay. So we also had a question in class, which was Jim, your question again. So, yeah, so
talking about this on the side, you use more, so it would not be worth operating all the way. So I could very you don't look at it at that point, you have to go to the point where margin cost.
Yeah. Okay. Yeah. So Dr. Turley came in and he pointed out that the logic of this point is correct. Like this is definitely these are the costs at 150 marginal, average, variable, and average total cost. But you wouldn't ever really analyze the graph in this way at one point. I was just doing it for the sake of showing you what's going on at that point. But if you want to know, the use of this graph is to know at what point you would produce. And so you could use this graph as if someone came to you and said, the foundation comes to you and said, we're actually going to do an average price of, they say $1,000 in this case. So we go to the point $1,000 and we find out in the short run, we want to make sure that the cost of producing is the same as, or the marginal cost matches up with the cost that they're offering us, average total cost. One thing that Dr. Turley came in and said, and this is a really important point, is that at some point, say the foundation came and offered us 500, which is right here, right? I might be tempted to just go right over here and say, okay, we'll produce this many. Maybe that's probably about 100. But that wouldn't be the case because even though this is where your marginal cost curve equals 500, that's not the only point where at which your marginal cost curve equals 500. This is the first point at which it does, where it's sloping downward. And over here again, probably about right here, it's going to equal 500 again. And this is the correct point at which we would quit producing. Or that's the quantity that, not we would quit producing, but that's the quantity that we would produce. That would be optimal for, in the short run, for $500 per garden price. And that's because at this point, when it's $500, when you look at this point on your marginal cost curve, what's the marginal cost when you're producing one more right there? It's going to be a little less than 500, right? 500 right there, but right here it'll be even less. So you want to capture all of these places where the marginal cost is below the cost of the price that they're offering you, right? Because right here, for instance, if $400 that you'd be spending on your marginal cost, but they'd be giving you 500. So even though you're below the point of your average total cost curve, right here it's it would be 933, and you'd only be getting $500, but you'd be getting more than the cost of producing that last garden, and so you'd be making up a little bit of those costs, even though in the long run it's not a good idea. In the long run, you're not going to make any, you're losing money, right? You're getting $500 each, but spending 933, that wouldn't be good. That's not good. But in the short run, you're going to find where the actual price of the good that is being offered in the market intersects with the marginal cost curve on its way up. Because then it's the case at this point that the next one is that you're going to buy might be, I can't do that, but the next point you're going to buy is going to be just above right there, because it's curving up right there. So if I offer you $500, and right here it's about $501, I'm not going to produce anything after that. Okay. Yeah. After this optimal point, your short run costs and your long term costs are not going to be optimal anymore. It's going to be the case of costs are larger than revenue in every. Okay, so part E says what part of the graph represents the short run supply curve and what part represents the long term. The short term supply curve is where the marginal cost curve is above our average variable cost. So I'm really sorry, guys, that this bar is in the way, but there's a line right here in marginal cost and average variable cost is right here. So if you all of this curve. Okay, and then the long run is going to be, it's also to include, the long run is going to be anything above this average total cost curve. So when your marginal cost is above the average total cost, so when, let's see. So say Foundation is offering us $1,500 right here. Then 1,500 we would produce at this point right here, and then after that, additional each additional one you'd be spending more than $1,500 on. So it wouldn't be worth it to sell anymore there. But it would be the case you would be selling there because you would have you're above your average total cost curve revenue. That's good. But after that point, each additional one is going to be bringing your average total cost up. Okay. Okay, so if the going rate for community gardens is $2,000, how many should you plant in the long run and the short run? So looking at $2,000 now. In the long run, let's do short run first. Short run's easier. You don't have to you can think about one less thing. So in the short run, we're going to produce wherever this intersects with the x-axis, which I think if we would have filled out the entire chart over here, if I had room for that, we would have figured it out. Yeah, I think it would have been 430 down here. Okay. And you would have done that, you would do that in the long run. You would do the also in the short run. Do that in the short run. Because that's where your marginal cost curve is sloping upward. So you know that the next one is going to cost you more. The next garden that you would have to produce would cost you $2,001, and you would only get $2,000 for it. So you wouldn't produce after that point. It would keep you losing $1 for every sale at that point. But you would be producing up to that point. In the long run, you would also keep producing because you're above your average total cost curve at that point, right? Average total cost there is probably somewhere near $850, about right here, and you're getting $2,000. So you want to keep continuing that business in the long run too, even taking into account your fixed costs. So if $2,000 is the price that they're offering, and where my cost equals $2,000 for marginal cost, and I just stop there. I think the next one's going to cost me more than that. I'm not going to produce any more. And then if you trace this down to your average total cost curve, you're getting $2,000, but your cost is yeah, you're getting a little bit less than $1,000 right there. So your extra your profit there is going to be $2,000 minus whatever cost added. So times the number of that you're producing, because you're above your total average total cost curve. So in the long run, that's what you look at. The price is $550. What are we going to do? In the short run, we're going to follow where $550 comes over to the marginal cost curve and the sloping up part. Because then we know the next one's going to cost us $551, and we're only going to get $550 out of it. We're going to stop there in the short run. In the long run, we'll keep producing if $550 is above the average total cost curve at the point at the quantity we'd be producing. And it looks like at $550, we'd be producing about 300 maybe of our gardens, and that at that point at 300, the marginal cost curve is below the average total curve. So even though you're making back some of your money in the short run, in the long run, the average total costs are still too great. Yeah, if it stays that way, you don't renew your rental agreement with your fixed cost or whatever it is. The price is 400. You do the same thing. You look at 400. Wouldn't stop all the way over to where 400 is going on the upward sloping marginal cost curve. That's where you produce in the short run. In the long run, you would see whether or not that is below the average total cost for that price. So $400 would be below your average total cost for that. And actually, it's the case that here $400. Yeah, yeah, it doesn't even make it on marginal. So I'm sorry about that. So the marginal cost curve in this point 400. Say it's about right here. This marginal curve right here is below our average variable cost curve and below our average total cost curve, right? So how many gardens are you going to plant? You're not going to plant any because yeah, because you're not even covering your average employee costs, what this is saying at that point. So you're looking at this point as a revenue point. And is this revenue going to recover the cost at that point? And it's not going to recover average variable cost, it's not going to cover average total cost. So you don't produce an edit situation. You don't produce until you get above, until the marginal cost curve is above or to the average variable cost curve. Yeah. So average variable cost, so I was just asked to go over average variable cost and average total cost. Average variable cost is basically the cost of your additional employees to produce additional output. It only takes into account your employees. Your average total cost takes into account your employees, your supplies, your long-term fixed assets, or things that you can't sell in the short. It includes all of the costs of running your business. Buildings, yeah, all of those things. So if it's the case that, so in this case, we only have one input, which is employees. Apparently, employees are the only thing you need to produce gardens in this case. And if you're not even, if it's not even covering the cost, the average cost of your employees at that point, then it's not, yeah, then you're losing money on that transaction. So that's why if it's below the average variable cost curve, you don't want to keep, or you don't want to keep selling at that price. You wouldn't start. Yeah, that'd be fine. Yeah. Okay, so I'm gonna let's see here. I think that's it for number one. Sorry that we took a while on that. One more question. So we want to find out where 550 is equal to. So we look at about 500. So he's just thinking about part G in the question for problem set 4, number 1. So if the price is 550, how many do you plant in the long run and short run, and what are your profits? Show profits on the graph. Okay. So if the price is 500, I'm sorry about how so if the price is $550, the price is $550 somewhere about right here. Well, I don't know if I drew it perfectly. It's the only thing. So yeah, so we'd actually so we're actually going to be we're at 500 at 550. Actually, I'm going to draw the dot. So at 550, Yeah, in the short run, you would produce this quantity where it lines up with the x-axis. And we don't have the actual equations for these lines. All we have is the numbers that we filled in over here. And so since there's no points over here at which I can see a 500 and I can see exactly where this point hits, then you're just going to be looking kind of about where. Yeah. So it's not, oh, he said that already? Okay. Yeah, it's okay to eyeball in that situation. Okay. Oh yeah, the graphic too. Okay, so to graph it, so it says, what is the question? It says, what are your profits? Okay, so the profit is area between your marginal cost curve and your total cost curve. So at this point, you would be looking at, so you're gonna, first you're just going to find out, so we're at 200, we found out where it intersects right here, right? It's about 255 or 260 or something. We're gonna find where that point is on our marginal cost curve and on our average total cost curve. And oh, well, for profits, if you actually make any profit, it will be above. So yeah. So if you're looking, say you were looking at the price point $2,000, you're looking at the market cost and the average total cost bill, and profit would be the area of this rectangle. But the length of this, yeah, yeah. Those are both. So to get the profit, what Jim just said is find the length of this, so you find out where what your marginal cost is at that point, what your average total cost is at that point. You subtract them, that gives you the width. It gives you what gives you the length is determining this where this point is on your x-axis. Because when the price is $2,000, your marginal cost curve is above your average total cost curve, there is profit. Whenever your marginal cost curve, like in the case of 550, your marginal cost curve is going to be below average total cost, then that's how much money you're losing in the long run. But it's still the case that if you keep producing, if you produce to that point, you will be minimizing your losses until after the marginal cost is greater than the marginal revenue. Yeah. Yeah, that's right. So what Jim just said is as long as you can keep making up your variable costs at a certain price point, then you produce at the marginal cost curve, which is correct. So that's only in the short run. In the long run, you don't do it unless you get to the average total cost curve and above that. And then at that point, that's where you graph your profit. So here we're graphing some losses, but we're losing our losses. Okay, I'm going to move on to number 2, the Walmart question. Actually, you know, I had a lot more requests in number 3, so I'm going to move to number 3.
Last one.
Which questions did you ask? Did you ask for the problem set? Okay. I can go back and talk to you about EFG. Since you're in here.
It's the questionnaire.
Yeah. 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 Okay, so now we're going to go over the Chinese wine example. Okay, so for the Chinese wine example, says that there's a YouTube video associated. So what we know is that 1.4 liters in China, so the Chinese drank 1.4 liters of wine per year in 2011, compared to 53.2 liters in France. And the production caused European winemakers to sell more cheap wine to China. The projection was that the Chinese might increase their wine consumption to 2.1 liters per year in 2011. So European wine competes with Chinese wine. European wine sold at about $10 per bottle. I'm going to write these things down. Okay, so 1.4 liters in China per person in China. And 53.2 in France. European wine is sold at $10 a bottle, and they compete with China, who sells wine at $5 a bottle. And this is the market in China. And so the Chinese direction is cheaper, selling for $5. Domestic market. The Chinese are conducting anti-dumping investigations. Dumping means that selling goods for less than the cost of production in international markets. It's illegal. So they are raising tariffs on wine that they perceive to be dumped into their Chinese market. Okay, let me see what the next question is. Yeah, I'm going to graph it. Okay, let me see here. Make sure that you guys can see me. Okay, so it says using total cost curves as supply curves, graph what the video is arguing is occurring as European winemakers try to sell their wine in China. Okay, so let me see here. I'm just going to make some price points for $30, $10, $10, $5. This is price. Quantity over here. And we don't really know what the quantities are at all. Okay, so what's happening in the video is the Chinese are arguing that, so if I understand correctly from the video, French wine costs more in France than it does in China, right? It costs way more than $10. But they sell it really cheap in that because they're trying to capture the market. Okay, so we have a couple of different examples of different countries. So it says that in France, wine costs, this is how much they charge for wine. How much did it say? $53? Oh no, this is how much they consume. Sorry, yeah, like, in fact, these are probably even an important fact. I'm sorry. So those are just the numbers of consumption in each country, and so those don't really apply as much. So I'm just going to focus on the prices instead. So what the Chinese are arguing is that in France, so let's see, French wine in France, it costs $30. And they're saying that if that's the price in France, then they shouldn't come here and sell it for $10 because that's dumping. So this is French wine in China. So the Chinese are increasing, essentially what the tariff does is increases the price of wine in China because there's still a certain cost of production. The French are still only willing to sell at a certain price point. They're still willing to sell at $10. When it gets to the market, in China, they're charged, a certain tariff per bottle, which actually raises the price. So this is what happens. The French are dumping their wine, supposedly, and the Chinese are saying, we're going to add a tariff so that we can, make sure that you're not just dumping your products here just so you can compete with our $5 wine. This is Chinese wine in China. And it also has some examples of like Spanish wine, right? We talked about in the video, Spanish wine, or was it mostly just the French wine? Just European wine? Oh, okay. Okay, so yeah. Okay, yeah. So I'll just use France and China as examples then. Okay, so in terms of average total cost, variable cost, and marginal cost curves, look at what the Chinese are arguing. So we're going to look at average total cost, average variable cost, and marginal cost over here, and see what the Chinese are arguing is happening according to this story over here. Okay. One second. I think this one's going to be pretty similar in reasoning to the Walmart problem. Okay, so what China is saying is that Here, I'm just gonna draw generic marginal average and total cost curves, and then I'm gonna draw one that compares it according to the situation. Okay, so we usually have a marginal cost curve that looks something like that. Average total cost looks something like that, average variable cost looks something like that. So we will say that this is we'll say that this is China. Okay, the black graphs are going to be China. Oh yeah, you're right. I'm sorry. Thank you. Average total cost. Sorry, I switched those. Okay, so yeah, that's good, guys. Okay, now I'm going to draw the European wine market according to this story. Okay, so what are we seeing in the story? Basically, the Chinese are saying that it costs more to, so it looks like it costs more to produce in France than they're actually charging in China. So if they're charging almost $30 in France, if that's where normally in France, that's where their marginal cost curve says to produce. And China is saying, so why are you coming to our country and selling at $10? You must be below your marginal cost. You must be below your average variable cost curve, or you're producing in a place where it doesn't make economic sense for you to do it, and you're doing it because you're trying to shut down the Chinese wine market so you can take over the market. So let's see here. So in this example, the situation is similar to China saying that they're the local shop owner, and Europe is acting kind of like Walmart in this situation. So they're saying that, let's see here, average total cost, average total cost. Okay. It's hard to look at when there's different graphs on there at the same time. Okay. Well, it'd be nice to overlay them so you can look at them a little bit, but yeah, so let's go back to just talking about Europe. So China is saying, so this is their supply curve, or their curves, and then your curve for their wine is something like here. So they're assuming that Europe is producing somewhere maybe down here. Okay, so China is arguing that Europe is doing something like this. They're saying your cost curve up this way, it's up there. It's more, your land is more expensive, your inputs are more expensive, your production is more expensive in Europe, your European wine, and your employees are more expensive than our employees, and so your marginal cost, average cost, and your average cost curves are actually above ours. And you're trying to sell your wine like at the lowest price possible. You're selling where it doesn't even make sense to sell it. Basically. You're selling below your average variable cost. Yeah, you're just trying to get. Yeah. Yeah, similar, right? And then after they capture the market, they could price differently. Okay, so that's yeah. Well, so if in a test he asks you to do something like this, and you have to make assumptions, you have to make a lot of assumptions about where you're going to put your curves and things, and that's okay if you justify your assumptions. If you just point them out and say, I made the assumption that European wine input, the cost of producing European wine is more expensive on every front, and
then justify it.
you wouldn't be able to. You could justify it with that assumption. You could say, assuming that European wine is more expensive to make, this is what the average marginal cost curve or this is what the marginal cost curve and the average cost curves might look like. And in that case, China would be right. Or you could say, I don't know, it depends on what the question on the test was, but you could also say, actually, I think the cost of producing wine is the same in both areas. And in Europe, they're just using more. And so they're at a place on their curve, which is farther. They're way over here on their curve because they sell so many, so their marginal cost is lower or whatever.
Yeah. So basically,
Mm-hmm. Yeah. Yeah. You feel like you could do that with assumptions on the test? Okay. Yeah, so that's number. It's 10 o'clock right now, so I'm going to stop there. Got through some problems at 4. Maybe next time I'll send another survey out, and so people can decide what we want to do next time. That first problem was just a long problem, so there's not much you can do about that, but yeah, so I'll send out another survey for what questions you want to go over next time, and I'll see you guys on Tuesday.